Okay, let's do another example. So example 2. F of x, y, and z, is equal to x squared yz, x y cubed z, and x y z to the fourth. Okay, well, let's see what we've got. The divergence of f, we said, is equal to del dot f. Well, del dot f is d1 f1 plus d2 f2 plus d3 f3, but we're not multiplying the d and the f. This means take the derivative of f. Well, the derivative of this with respect to x is going to be 2xyz, xyz, plus this one. The derivative with respect to y is going to be plus 3x y squared z. And the derivative with respect to z of this one is going to be plus 4x y z cubed. This is our divergence of the particular vector field. Okay, so now let's go ahead and do the curl of the vector field. The curl of this vector field, well, it is equal to del cross f. And del cross f, well, is symbolic, so it's going to be I, j, k. Let's do capital D notation here, d1, d2, d3, and we have x squared yz, we have x y cubed z, and we have x y z to the fourth. Okay, so now let's go ahead and expand along the first row. It's going to be the derivative with respect to y of this minus the derivative with respect to z of this. The derivative with respect to y of this is xz to the fourth, xz to the fourth. The derivative with respect to z of this is xy cubed. This is the I component. Minus, now we go to the next one, the derivative with respect to x of this minus the derivative with respect to z of this. Derivative with respect to the first variable, which is x, the derivative with respect to the third variable, which is z. That's what's going on here. This times this times this, except it's not times, it's symbolic. It means operate on this. Okay, so the derivative with respect to x of this is yz to the fourth minus the derivative with respect to z of this, x squared y. This is the j component. Okay, we're almost done. Now the derivative with respect to x of this minus the derivative with respect to y of this. So the derivative with respect to x of this is going to be y cubed z minus the derivative with respect to y of this is going to be x squared z. And again, I hope that you are confirming this for me, because there's lots of x's, y's, z's, ij's, k's floating around. Y cubed z, x cubed x. There you go. So I will go ahead and actually leave it in this form. That's the first coordinate function of the curl, that's the second coordinate function of the curl, and that is the third coordinate function of the curl. Actually, you know what? Let me go ahead and write it out. It's not a problem. So go ahead and erase these stray lines here. So we've got x z to the fourth minus xy cubed. That's the first component function. We have y z to the fourth minus x squared y, and then we have y cubed z minus x squared z. Notice the divergence is a scalar, the curl is a vector. It has three component functions. It has an x, a y, and a z. At a given point, x, y, z, there is some vector pointing in some direction away from that point. And that's the whole idea. And again, it's all based on this notion of what we call an operator, and it's just a symbolic way of telling you what to do to a given function. It's a unifying scheme. So we have this thing, we can take the divergence and the curl of a vector field. We want to be able to express that in terms that we know. Well, if we gave this, we called it a del operator, we gave it a symbolic representation as d1, d2, d3 as a symbolic vector. If we do del dot f, we get divergence of f. If we do del cross f, we get the curl of f. That's it. It's just a unifying scheme. Okay, thank you for joining us here at Educator.com for divergence and curl. We'll see you next time for a discussion of the divergence theorem in 3 space. Take care. Bye-bye.